Hi guys, welcome to this video on the conservation of mass, where we're going to be looking at closed and enclosed systems. So if we start off with the definition then, the conservation of mass says that the mass is always conserved in a chemical reaction. So the first example of this we're going to look at then is a precipitate reaction. Now this is an example of a non-enclosed system because there is no lid that's going to stop any gases from escaping. Because it's a precipitate reaction, there are no gases to escape. So I'm starting off with 203.48 grams of copper sulfate and sodium hydroxide. I'm going to react them together and you'll see a precipitate forming. So if I put everything back onto the scales, I should expect the mass to stay exactly the same, which as you can see it has. If I stick with a non-enclosed system then and look at a reaction involving zinc carbonate and hydrochloric acid, the difference here is that a gas is produced. So if I start off with a mass of 168.08 grams between the two and then react them together, I should see a difference. Now this is because carbon dioxide gas has been produced, and because there's no lid, that carbon dioxide has escaped. So as you can see, the mass has gone down to 167.98. So how do we prove that it is conserved during a reaction then when there's a gas? That is where you actually put it into a closed system. In this case, it means using a bung. So my starting mass here was 210.25, and as you can see, reaction is occurring and the mass is staying the same. I'll shake it to keep that reaction going and it should go back up to 210.25. So in summary then, the mass of the products is always going to be the same as the mass of reactants. So if you put in 12 grams, you'll get 12 grams out of it. Secondly, in a closed system, the mass will always stay the same, and that means having it closed, so there's a bung, for example. In a non-enclosed system, the mass will stay the same if it's a solid or a liquid produced. However, if you get a gas, it might look as though that mass is going down, but if you were to collect the gas, the mass would also stay the same. Now to explain this, we're going to use the reaction between hydrogen and oxygen to make water. Now as you can see here, this is an unbalanced reaction. I have more oxygens on the left than I do on the right. Now in any reaction, the number of atoms on the left needs to be the same as on the right. So what we're going to do is we're going to balance it. So I'm going to start off by doubling the water molecule. Now this gives me 2 oxygens on the right and 4 hydrogens on the right. So my oxygens are balanced. So the next thing I need to do is put a 2 in front of my H2 and double that. So that gives me an extra 2 hydrogens, which is now balanced. Now, because I've got 4 hydrogens on both sides of the equation, they all have the same mass, so the mass of hydrogens is the same, and it's the same with my 2 oxygens. And this gives me the same mass for my reactants and my products. And it also helps to prove that atoms are neither created nor destroyed. During a chemical reaction, they get rearranged, but they don't actually get created or destroyed. So mass and the number of atoms always stays the same. Let's move on to a practice question then. So this one says, in a chemical reaction, zinc reacted with hydrochloric acid in a beaker to form zinc chloride and hydrogen. And you've got the balanced symbol equation here. Zn plus 2HCl goes to ZnCl2 plus H2. Question 1 is, the mass of zinc was 4 grams and the mass of hydrochloric acid was 8 grams. What was the total mass of the products? So bear in mind, this isn't asking you for zinc chloride or hydrogen, it's asking for both of them together. Question 2. When measured, the mass of the products came to 10.6 grams. Explain why the mass was lower than expected. So think back to what we've gone through this video and see if you can answer it. The clue for you is it's in a beaker. And then finally, question 3. What could be done to make sure that mass does not go lower? So to make sure it stays at what it should have been and what you calculated in question 1. Pause the video, have a go at the question, and we'll see how you've done in a minute. Okay, let's go through and see how well you've done then. So if we start off with question 1, the mass of zinc was 4 grams and the mass of hydrochloric acid was 8. So if that's both of our reactants, the mass of the products has got to be a combination of the two, which is 4 plus 8 is 12. So you get 1 mark for 12. I would always show you marking your working just in case. Question 2. When measured, the mass of the products came to 10.6 grams, which is less than our 12 we worked out in 1. why is that lower than expected? Now the key here is to look at the equation. So we've got zinc is a solid and hydrochloric acid is aqueous, and then our products are aqueous and a gas. So the first thing to notice is hydrogen gas is produced. The second thing, if that's been produced, our beaker here is not in a closed system, it's a non-enclosed system. So it's a non-enclosed environment, so the gas has escaped. In some mark schemes you might get away with just saying it's a non-enclosed system. You might get away with saying the gas has escaped. I would always try and put both. So question 3 then, what could be done to make sure that the mass does not go lower? Nice and simply, put a bung on it or make it a closed system. Okay, that pretty much sums up this video. So we'll move on to the review question, which is explain the conservation of mass, and in your explanation you should include why in a closed system mass stays the same, but in a non-enclosed system it can go down during a chemical reaction. And that ends this video.
Hi guys, hopefully you've enjoyed the video. If you have, click the subscribe button down below and visit the website mrbarnestc.com for more.